Integral transforms. So the integral transform of function f of t, that is I of f of t, is g of alpha, is defined as the integral from a to b f of t with the k of alpha t. This is the integral transform of f of t with respect to the kernel k of alpha t. It is actually a mapping from t space to alpha space. Based on different kernels, we have different integral transforms. And the g of alpha is equal to 1 over root 2 pi integral minus infinity to infinity f of t e raised to I alpha t dt is the Fourier transform of f of t with the kernel e raised to alpha I alpha t, and g of alpha is equal to integral 0 to infinity f of t e raised to minus alpha dt is the Laplace transform, and g of alpha is equal to integral 0 to infinity f of t gen of alpha t dt is the angle, and g of alpha is equal to integral 0 to infinity f of t raised to alpha minus 1 dt is the Milling transformation. Here we are discussing Fourier transform. The Fourier transform g of alpha is equal to 1 over root 2 pi integral minus infinity to infinity f of t e raised to I alpha t dt. The Fourier cosine and sine transforms are gc of alpha, that is cosine transform, root 2 by pi integral 0 to infinity f of t cos alpha t dt, and the sine transform gs alpha is root 2 by pi integral 0 to infinity f of t sine alpha t dt. Fourier integrals. Fourier coefficient over the interval minus L to L is an is 1 over L integral minus L to L f of t cos n pi t by L into dt, and bn is 1 by L integral minus L to L f of t sin n pi t by L into dt. We are substituting the values in fx is equal to 1 over 2, this is a0 by 2, 1 over 2L integral minus L to L f of t dt plus 1 over L summation over n is equal to 1 to infinity cos n pi x by L into integral minus L to L f of t cos n pi t by L into dt. This is an plus 1 by L summation over n is equal to 1 to infinity sin n pi x by L. This is bn. Now arranging 1 by 2L integral minus L to L f of t dt plus 1 by L summation over n is equal to 1 to infinity integral minus L to L f of t, taking all cos n pi t by L cos n pi x by L plus sin n pi t by L sin n pi x by L into dt. This is cos a cos b plus sin a sin b form, that is equal to cos a minus b. Therefore this is cos n pi by L t minus x, that's equal to 1 over 2L integral minus L to L f of t into 1 plus 2 into summation n is equal to 1 to infinity cos n pi by L t minus x dt. Now this in the curly bracket, that is 1 plus 2 into summation over n is equal to 1 to infinity cos n pi by L t minus x can be written as summation over n is equal to minus infinity to infinity cos n pi by L t minus x. Here the term 1 is for n is equal to 0, 2 comes for n from minus infinity to 0 and 0 to infinity. So now we can substitute this value here. Therefore f of x is equal to 1 over 2L integral minus L to L f of t integral summation over n is equal to minus infinity to infinity cos n pi by L t minus x into dt, multiplying and divide by the pi and arranging, this is equal to 1 over 2 pi integral minus L to L f of t pi by L summation over n is equal to minus infinity to infinity cos n pi by L t minus x into dt. Now I am approaching L to infinity, so that pi by L is delta omega and n pi by L is equal to omega. So that is n pi by L is omega and pi by L is delta omega with L tends to infinity. Limit L tends to infinity pi by L, this is pi by L summation over n is equal to minus infinity to infinity cos n pi by L t minus x. This is goes to integration and this is goes to d omega, that's equal to integral minus infinity to infinity d omega cos n pi by L is omega into t minus x. So this is equal to 2 times, this is an even function, therefore 2 times integral 0 to infinity d omega cos omega t minus x. Therefore fx is 1 over pi integral 0 to infinity d omega integral minus infinity to infinity f of t cos omega t minus x dt. This is the Fourier integral. Find the exponential form. Since cos omega t minus x is an even function of omega and sin omega t minus x is an ordered function of omega, we have f of x 1 over 2 pi integral minus infinity to infinity d omega integral minus infinity f of t cos omega t minus x dt. If you write 1 over 2 pi integral minus infinity to infinity d omega integral minus infinity to infinity f of t sine omega t dt is equal to 0. We can combine these two equations and we can write it as f of t into cos omega t minus x plus I sine omega. So this is equal to, we can write e raised to I omega t minus x. So this is f of x is equal to 1 over 2 pi integral minus infinity. I have taken the x term here, that is e raised to minus I omega x. This is e raised to omega t minus s, that is equal to e raised to minus I omega x and e raised to I omega t. So this is f of x is 1 by 2 pi integral minus infinity to infinity e raised to minus I omega x d omega into integral minus infinity to infinity f of t e raised to I omega t dt. If the order of integration is just reversed, that is f of x is equal to integral minus infinity to infinity f of t into integral 1 by 2 pi integral minus infinity to infinity e raised to I omega t minus x d omega into dt. The one in the curly bracket is delta t minus x. Delta t minus x is 1 by 2 pi integral minus infinity to infinity e raised to I omega t minus s dx d omega. That is a Dirac delta function. Therefore, f of x is integral minus infinity to infinity f of t delta t minus x dt. Now let us define g of omega is equal to 1 by root 2 pi integral minus infinity to infinity f of t raised to I omega t dt. This is the Fourier transform. Fx is equal to 1 over root 2 pi integral minus infinity to infinity g of omega e raised to minus I omega x d omega. This is called inverse Fourier transform. Of course, we have g of omega is 1 over root 2 pi integral minus infinity to infinity f of t e raised to I omega t dt. So we can write e raised to I omega t as cos omega t plus I sin omega t. If f of x is an even function, then gc of omega is 1 over root 2 pi integral minus infinity to infinity fct cos omega t dt. This is going to be an odd function that vanishes, and gc of omega is equal to this 2 times. Therefore, square root of 2 by pi integral 0 to infinity fc of t cos omega t dt. And also we have the inverse transform. F of x is equal to 1 over root 2 pi integral minus infinity infinity g of omega e raised to minus I omega x d omega. That's equal to square root of 2 by pi integral 0 to infinity gc of omega cos omega x d omega. This is the cosine transform and inverse cosine transform. Similarly, if f of x is an odd function, then gs of omega is square root of 2 by pi integral 0 to infinity fs t sin omega t dt, and the inverse one is square root of fs of x is equal to square root of 2 by pi integral 0 to infinity gs of omega sin omega x d omega, and these are not the Fourier sine transforms. We have f of t is e raised to minus alpha modulus of t for alpha greater than 0, and to find the Fourier transform, we have Fourier transform g of omega is 1 over root 2 pi integral minus infinity to infinity f of t e raised to I omega t dt. So this is from first integral from minus infinity to 0, where t is equal to minus t, therefore e raised to alpha t plus I omega t. Another from 0 to infinity where t is plus t, therefore e raised to minus alpha t plus I omega t. On integrating and applying the limit, we have square root of 2 by pi alpha by alpha square plus omega square. And this is a Gaussian function in e raised to minus alpha t square for alpha greater than 0. We want to find the Fourier transform. We have g of omega is 1 over root 2 pi integral minus infinity to infinity f of t e raised to I omega t dt. F of t is n e raised to minus alpha t square, and e raised to I alpha t is cos omega t, I omega t is cos omega t plus I sin omega t, and this is 0, and this is equal to, this integral can be calculated using this standard form. Integral minus infinity e raised to minus alpha x square cos kx dx is equal to square root of pi by alpha e raised to minus k square by 4 alpha. Using this integral, here we have n g of omega is equal to n by square root of 2 pi root pi by alpha e raised to minus omega square by 4 alpha. That's equal to n by square root of 2 alpha e raised to minus omega square by 4 alpha. That means the Fourier transform of n e raised to minus alpha t square is n by root 2 alpha e raised to minus omega square by 4 alpha. That means the Fourier transform of a Gaussian is another Gaussian, but in this is in omega space, this is in t space. As the value of alpha increases, original Gaussian, that is e raised to minus alpha t square, become narrower, but the transform become wider. Here we have a finite wave train. This is a finite wave. It is cut by or clipped by a cursor, or we make a window by modulus t less than n pi by omega 0 is sine omega 0, and modulus of t greater than n pi by omega 0 is 0. This correspond to n cycle of original wave train. So this is an odd function, and we can use the Fourier sine transform, which is gs omega is square root of 2 by pi integral 0 to infinity fst sine omega t dt. This fst is sine omega 0 t for 0 to n pi by omega 0. Here we can use cos a minus b minus cos a plus b by 2. That is this one, cos omega 0 minus omega into t minus cos omega 0 plus omega into t, and integrating, this is gs of omega square root of 2 by pi sine omega 0 minus omega by t by 2 times omega 0 minus omega minus sine omega 0 plus omega into t by 2 times this omega 0 plus omega over the limit 0 to n pi by omega 0. And substituting, we have this one. And looking for large omega 0, if omega 0 is large, this will be cancelled, and this is approximately equal to omega 0. And for omega approximately equal to omega 0, only the first term have some importance, and we can calculate the maximum value, and all. For plotting this, it will be like this. At omega is equal to omega 0, this has a maximum. This it is 1 over root 2 pi n pi by omega 0. This is a single slit diffraction pattern, and so anyway, this is the Fourier transform of the finite wave train. Here we have f of x is 1 for modulus of x less than 1 and 0 for modulus x greater than 1. It's a symmetrical finite step function. At gc of omega, the Fourier Cosine transform, and taking the inverse transform, we have to show this one. So we have g of omega is square root of 2 by pi integral 0 to infinity of x cos omega x dx, Cosine transform. So this is equal to 1 for 0 to 1 cos omega x dx. Let's integrating and simplifying, we have square root of 2 by pi sine omega by omega. Now the inverse transform, fs is equal to square root of 2 by pi integral 0 to infinity g of omega cos omega x d omega. That's equal to g of omega is this one, integral 2 by pi integral 0 to infinity sine omega cos omega x by omega d omega. We have to show that the Fourier sine and cosine transform of e raised to minus at are these the sine transform and cosine transform, and then we want to show these two. Now let us do first one. Sine transform is equal to square root of 2 by pi integral 0 to infinity f of t sine omega t dt. That's f of t is e raised to minus at. First we can calculate this one, integral 0 to infinity e raised to minus at sine omega t dt. That is sine omega t first function integral of second, using the first function integral of second minus integral differential of first integral of second. So we have omega by a cos omega t. So this is 0 0, and we have this one, and again integrating by parts here, cos omega t e raised to minus at by first function integral of second e raised to minus at by minus a minus integral differential of first integral of second, and therefore e raised to minus integral 0 to infinity e raised to minus at sine omega dt is omega by a square minus omega square by a square integral 0 to infinity e raised to minus at sine omega t dt, or 1 plus omega square by a square into integral 0 to infinity e raised to minus at sine omega t dt is equal to omega by a square. This one. Therefore, integral 0 to infinity e raised to minus at sine omega t dt is, this one is equal to, taking this side and simplifying, omega by omega square plus a square. So substituting in last equation 1, gs of omega is square root of 2 by pi omega by omega square plus a square. Now the cosine transform is root square root of 2 by pi integral 0 to infinity f of t cos omega t dt. This is f of t raised to minus at. Now taking this as equation 2 and taking this and simplifying, integral 0 to infinity raised to minus at cos omega t dt is equal to cos omega t by parts. First function cos omega t into integral of second minus integral differential first, that is minus omega sin omega t raised to minus at by a. So this equal to 1 by a applying the limit 1 by a minus omega by a sin omega t e raised to minus at. Again integrating and simplifying, we have 1 plus omega square by a square into integral 0 to infinity e raised to minus at cos omega t dt is equal to 1 by a. From that, integral 0 to infinity e raised to minus at cos omega t dt is a by omega square plus a square, and substituting in equation 2, gc of omega is square root of 2 by pi a by omega square plus a square. Now b, we have the inverse transform, that is fs of x is equal to square root of 2 by pi integral 0 to infinity gs of omega sin omega x d omega. Substituting e raised to minus ax is equal to this one in the square root of 2 by pi integral 0 to infinity gs of omega we already calculated is square root 2 by pi omega by omega square plus a square sin omega x d omega, and simplifying we have this one integral 0 to infinity omega sin omega x by omega square plus a square d omega is equal to pi by t raised to minus x. Now for the cosine, fc of x is equal to square root of 2 by pi integral 0 to infinity gc of omega cos omega x dx d omega, that is e raised to minus ax is equal to square root of 2 by pi integral 0 to infinity gc of omega is this one square root of 2 by pi a by omega square plus a square cos omega x d omega. From that, integral 0 to infinity cos omega x by omega square plus a square d omega is equal to pi by 2a e raised to minus ax.